What up, hackers? We doing some sci-fi stuff today? Thanks for having me. I'm glad technology has brought us together. And for those of you who are in person at the con, I hope, if you see me, you say hi. If you're developing software, you likely have a complex dependency graph. There's simply no way to do what we do without the work that has come before us. So, how do we deal with the swell of low quality, insecure code that is just waiting to be plucked into your project? I say, embrace the crazy world of unchecked, unsecure code and help it grow. Let's talk about why and how. Okay, let's level set. We all stand on the shoulders of giants. Whether or not you're developing software, you are using software that is either open source or has open source libraries in it. And some businesses market themselves as defenders against, they defend you against open source. So it's really hard, though, to imagine where we'd be without the sharing of code and of that knowledge. And in fact, some of your employees, whether you know it or not, may be contributing to open source on their own time. And as a business, it may not seem obvious at first, but this is definitely a win. And we can talk a little bit about how you can bolster value in this relationship that some of your employees may have with open source. We'll talk a little bit more later about bolstering that relationship and leveraging the value there. But for right now, we'll talk about security because that's why we're all here, right? In the past, InfoSec professionals have had to act like mad dogs to get traction with securing important shared computer resources. In some ways, this is carried over into modern day application security through a dogmatic approach to software development. This has left some newer security professionals with a myopic take on software development. Are you affected by this myopic attitude? Let's test it out. If I was to say, not all code needs to be secure, what comes to mind? Do you instantly think, wrong? Or we can't even consider that to be the case? Or don't tell developers that, for heaven's sake. If you thought something like this or anything in the realm of this talk is for you, I would like to talk about things that can be overlooked. We'll talk about how vendors prey on this dogmatic approach, and we'll see how it's to the detriment of you and them. Also, you may be leaving free knowledge on the table if you have this attitude. So, let's get grounded. Let me be clear. If the internet can touch an instance of it, it better be secure. I'm not trying to be bombastic or create clickbait. By saying not all code needs to be secure, I'm not saying that all code should be insecure. That's simply not the case. What this statement is meaning is that third-party code may or may not fit your application threat model. By assuming all software should be secure, you shift your ownership of some portion of your threat model to an unknown party. And that unknown party you will probably blame later when things go wrong, let's be honest. So who am I that I'm saying all this stuff? Why should you listen to me? How do I know what I'm talking about? Well, you may already recognize me as being unleat. Remember this one? Good times. I professionally worked my way into network engineering from frontline phone support role at an ISP in the late 90s. I moved into software engineering after I found out I enjoyed working on software. And later I made the steps to actually get better at software engineering. I've been a professional developer for nearly 20 years now, and I've always been a community wallflower. In the last couple years, I have been trying to go legit. As some can attest, this is difficult. Also, hire me. I specialize in a particular platform, And you can find out more on my LinkedIn profile. Tell me you saw this. Over the years, I have been involved in various developer ecosystems. I've watched some ecosystems mature and then fracture, and some of them die. Some I watched just totally fail. I was involved when some large enterprises responded to the epiphany that open source works, and then the awkward efforts that they made to make it work for them. So I've seen good decisions, I've seen bad decisions, and I've witnessed breaches. Supply chain attacks have recently been the talk of the town. Are you tired of hearing about it? But it is important. You should probably check out some of the other talks given at conferences around. And I think there was one just earlier in our very own AppSec village. Supply chain attacks might be simply a suspect chip on a circuit board, or more likely, a compromised build server injecting malware. Or it could simply be a private package name on a public package. Supply chain attacks aren't new, and you may remember the LeftPad debacle just a couple years ago. Or maybe some of you remember some older examples. Some vendors blame it on open source. But if you look closely, the most successful were aimed at proprietary software and used exploits of proprietary software. That is not to say that open source wasn't involved or that it's not a risk. In some ways, there are definitely risks on both sides. Do you understand, though, what your software supply chain is and what all is involved? Where does your software come from that you use in your supply chain? Do you know all of your transitive dependencies? Those are dependencies of dependencies. Do you have an inventory of all the components of your DevOps tooling? That's part of it too, because software supply chain is a complex topic, and we won't fully be able to explore it here today. Simply reviewing the names of what might be involved in a Kubernetes cluster would take a whole conference of its own. So the point is that to get a handle on software supply chain in general, we need to look beyond the primary libraries that make up our apps, because it involves everything that is involved in getting our application, our code, to production. But right now, though, I'd like to talk about some roles and relationships that can give you a grip on software supply chain. Just like not all dependencies are open source, not all supply chain issues are security only. The first place we should look is at getting a hook into the developer mindshare by understanding a little bit of how they relate to security specifically. Whether or not a developer knows the term, they develop under a certain assumed threat model. To a developer, threat is a term that is broader than security and extends to other undesirable input, output, and computational side effects. Generally, what InfoSec refers to as security is a subset of quality criteria to a developer. Unfortunately, some developers see application security as obnoxious, overpaid, sometimes hostile QA people. If this is the case, enabling some understanding of the developer's perspective of a threat model can go a long way to bridging the purpose of the two perspectives, that is, the developer and security. Because educational systems often neglect security, a developer may have a threat model that has not been thoroughly acquainted with some aspects of security concerns. Early on, it may be mostly influenced by issues they discovered in the wild. So, how does a developer threat model develop? That could be a key to understanding the many aspects of your software supply chain. For some, developing started with curiosity. How does this thing work? How can I make this thing do that thing? A person, we'll call them Alice, finds out that they can use software to make things happen. Then they figure out that they can do other things by writing software to satisfy their curiosity. Then Alice finds another person who is experimenting with the same things that they were. We will call them Bob. And so they shared code in hopes of growing and learning from each other's perspective. And Alice might tell Bob, don't do such and such because it lets out the blue smoke monster. Alice learned through experience and experimenting. And Bob returns the gesture and tells Alice, I did this that you said, and it didn't work. In my case, you need to change something different. This learning exchange may or may not include security. The information being exchanged is just not considered to be explicitly security or quality at this stage. The code at this stage is not anything you'd want to put into production. However, someone might come along and do just that. We'll call him Elliot. He sees some functionality, and maybe he wants to be the first to put it into a product. So he plucks it and puts it into his software running on the internet, and can you guess what happens? He gets hacked. Who is he going to blame when it's clearly his fault for not paying attention to the code that he picked up, like chewed bubblegum from a sidewalk? If he complains and blames them publicly, this bad experience may discourage Alice from doing any more shared learning. At best, it's a burden that they didn't ask for. At worst, this threat model could get personal and turn into a deal breaker, sending them looking for a different hobby. And that's obviously something that we don't want. We need more programmers. However, if Elliot sees his mistake, he can responsibly disclose how to enhance the code, and then Alice and Bob and anyone else joining in later can see this and learn from it and create better code for Elliot to use, coincidentally. This doesn't need to be so formal, but I hope you can draw the lines from this circumstance or simple example to more formal circumstances, and perhaps draw ways that you can encourage developers to increase their quality and security in the things that they do share in order for them to share them in an elevated context. Okay, I know you've been dying to talk about this. Let's talk about that insecure code. For a minute, let's look at code in this way. It can be likened to clothing. In the past, I've been known for going to lots of concerts. One of the things people like to do at concerts is dress up. Sometimes they dress up fancy. Sometimes they just want to look nice and appropriate. And sometimes they experiment with more wild clothing. Sometimes they just want to get attention. You've probably seen some pictures from Burning Man or Coachella in your social feeds. Yeah, we're talking about those people. Some people use these places as a safe place to experiment and maybe develop their own style. They can get to know what they are capable of pulling off, what looks good on them. However, if you're going to climb Mount Everest, you should not pick from the outfits that they wear at Coachella, because they do not match the threat model of your journey. If you expect to summit wearing some little sparkly fanny pack around your neck in a swimsuit, you're probably not going to have success. You're probably not taking it seriously enough. In the same way, you would not choose code that is not fit for your purpose. If your purpose is a production application, you would not choose Coachella. However, If you want to show the effects of prolonged exposure in sub-zero temperatures, you could take that outfit and start up Mount Everest. This would be likened to much of what's done here at DEF CON. You see a lot of, this seems like a bad idea. Let's see what it really happens. This is really the only way that bad quality or insecure code should be permissible in teaching. That is to demonstrate how and why you don't do some things. One of my pet irritations is when a person teaching coding says, don't do this in real life, and proceeds to explain a real life scenario with some code that is sub-quality and insecure. The only time the example code should be incorrect or insecure is to show exactly that insecurity or how it's not correct. Example code should always be secure. It's just like the old adage, or the old illustration, if you want to be able to identify counterfeit forgeries, you study the real thing. If you study with a forgery, your model will be inherently flawed. And us technical people in this age of machine learning understand this. If you want to create the hot dog, not hot dog app, you feed your model hot dogs, not everything else. There are some people who love to experiment. They don't want to code in their day job. All they want to do is express themselves and learn something in a stress-free setting. They have no intention of taking that next step to production or to offer their software as a service. Innovation takes many forms and comes from many places. Sometimes these experiments innovate in ways that impact privacy or security, but this shouldn't prevent the experiment from happening. How much better when this sort of thing happens, this innovation, out in the open where anyone can learn from it, and if need be, they can learn how to mitigate it. Nearly anyone can place packages on a public feed. I should know, I have a few out there. As security professionals, we need to recognize that the fundamental purpose of public feeds is to make experimentation and creation easier and faster. I've not found any myself, but I would be interested in hearing about mechanisms built into package feeds to be able to differentiate experiments from production-worthy code. Many feeds offer version suffixes, and they've found some adoption, but if you're not intending on releasing your code, you're not going to go through the trouble of putting beta on it either. Right now, public feeds contain a gambit of quality and security. The uninitiated developers are likely to grab any old package from their feed that makes their job easier. If the feed is blocked in some misguided attempt to control the flow of outside code into the application, developers will turn to their favorite community site, blog, or even Twitter if they're desperate. Each platform and framework may have multiple feeds and sources. You can't block them all. So how do we manage? Even if we come to grips with the fact that insecure code needs to exist, what can we do to keep our own software supply chain up to our standards of quality and security? So let's review some of the things that everyone is doing, or should be doing. The fundamentals. Update often, automate scans, run them often, code review, pen test, work to remediate quickly. Maybe an internal package feed is a good way to stay on top of your dependencies. I've seen a process implemented around the process of getting new packages into the internal feed, the package being approved by a qualified developer. Then all builds are forced to use only the approved feed, and anything not approved breaks the build and usually prevents the merge. It seemed to work out pretty well. One place I worked at, someone thought that it was a great idea to package NameCamp on the public feed. Buy me a beer later, and we can discuss all the ways that that can go wrong. Another place I worked forbid their developers from any outside code. And this created an issue with learning and problem solving, and in just regular flexibility. It was really a pain to block all the outside code, and so eventually it failed. Sometimes you just need to look at the documentation. What about forking a project to preserve its state? This is no different than never upgrading a package. The risk is high that you'll just get stuck with flaws and vulnerabilities. Don't do it. If you can get your static analysis, security testing, software composition analysis, and everything from the same vendor, some people feel that having it all in one package is all that they need to cover all their bases. And we've talked about some of the ways that that's not the case. Something that's often overlooked, though, when you get things from a vendor is, and it's rarely reported on, is how the vendor treats open source. If they are doing scanning and they find a flaw, are they responsibly disclosing, or are they secretly passing on a patch to their customers and never giving back to that project? This, by the way, may be in violation of some open source licenses. I don't know, I'm not a lawyer, but it's just kind of a jerk thing to do. When a library gets a flaw, are you more likely to abandon it instead of responsibly disclosing the flaw? We might be able to work with communities and develop a rapport and fast turnaround in order to satisfy some of those needs. According to GitHub's 2020 State of the Octoverse, vulnerabilities often go more than 4 years before they're disclosed. So maybe if we disclose them more often ourselves, we'd be doing the responsible thing and we could improve that statistic. Not every issue needs or gets a CVE. Sometimes the only place you can know of a security issue is in the issue tracker on the project itself. With open source, you can watch these, although it might become quite a chore to keep up on all those packages. How many packages do you have in your feed again? So, do you ever feel like the kaiju just know your name and are coming for you? Sometimes trusting just seems way more simple. So maybe how can we do some of that? Phil Hacked, a former GitHub employee, outlined 4 questions to ask to establish authorship in a post entitled Trust and NuGet back in 2013. It asked, who is the author? Is the author trustworthy? Do I trust that this software really was written by the author? Is the author's means of distributing software tamper-resistant and verifiable? Phil has written several times about package management and security. I suggest you take a look at his blog. He even outlines some suggested steps to change maintainers, such as consider a change of ownership a SymVer breaking change. On popular packages, offer reputation information about the new owner. Work with open source foundations to find and vet maintainers. Don't leave the burden on the maintainer or they might just delete it and walk away. You may think that just paying for a package allows you high level of trust. The expectation really is the difference with a proprietary feed. Because of this, I would still start with the same level of investigative trust as a public feed. It would be good to determine what would prompt you to revisit this and plan to repeat it down the road. Something that has been suggested by vendors is rating systems for packages. However, one very important thing is left out by those suggesting such a system. No one asked to be rated. Not every piece of code is created for altruistic motives or even to be consumed on enterprise products. I'm not sure if you noticed, but people really don't like to be labeled. So here are some guidelines if you want to start a rating system. A rating system must be opt-in. If you start slapping labels on unsuspecting code, you are telling them that they have no choice but to maintain your standards. Ratings must be simple. I shouldn't have to do math or look it up on a matrix to make sense out of it. Be specific about flaws and vulnerabilities, and link off to OWASP and MITRE descriptions. Each cited flaw should be given a specific platform standard, well-documented mitigation. Also, mediation should allow for explanation and manual approval. And the reason behind that is just because you think it's wrong doesn't mean it wasn't done on purpose, and false positives happen. The positive side of open source is that the source can be examined. But how often is this really done? If projects were given the opportunity to opt in, it would also give us a place to start doing secure code reviews and testing them for quality and security. At the end of the day, there are really only 2 groups of code. If the maintainer is able to put the effort in and the project is able to be publicly approved to be adequately verified, We could indicate that it is being maintained as an adequately verified product, AVP. Also, by the way, my favorite comic book franchise. This way it's made explicitly separate from the Coachella without any action required on the part of the experimenters. Offering a community a way of differentiating their product may enhance the motivation to provide higher quality and security. Developers may want to go the extra mile to be recognized. Feed providers can enable trust building by passing this information on in a simple way, so that perhaps offering an AVP specific feed even. Companies can get involved by offering resources for carrying this out. They can offer compute resources as well as reviewers, perhaps earmarking time of their developers to devote to the community. Do your AppSec personnel get trained to do secure code reviews? There's no doubt this is a good skill for them to have. However, I've heard from several that do it that reviewing all of the code a couple of times a year just doesn't really scale. And then if you think about a situation that's like if you were in some place that you didn't know the laws and you were being stalked by law enforcement that kept arresting you without explaining why, the simple solution to reduce your violations would be to tell you what the laws were. In the same way, giving developers the chance to have the knowledge that they need makes sense. You can make policies and standards easy to access. Even better, make them easy to quote in merge request comments. Contrary to many InfoSec stereotypes, developers like to learn. Make sure they know where they can find best practices. Offer to help with clearing the way to implementing processes to enhance quality and security, and let them own it. During one plane trip, I sat beside someone that was criticizing the pilot. Tell me if I'm wrong, but if they want to have safe pilots, they train the pilot, not the passengers. So while it seems harsh, if you're not a developer, you're not writing code, you are a passenger. The highest impact on quality from training is going to be the obvious choice of the developers. When they are trained, offer to help them to put the procedures in place to make them successful with their new knowledge. Have you thought about identifying key people in the open source community, perhaps, that you could identify for sponsorship? You might be amazed by the result. When developers learn, they often get excited. They might return to the group, start using what they learned and share it with others. But just be careful not to douse their fire with your grilling. It has never been a better time for a company to get involved in their open source communities. It would be great to see communities shift their attitudes about open source to large-scale communal ownerships. Managing proprietary third-party dependencies is different than open source. It is obvious we need to scrutinize our code dependencies, whether proprietary or open source. The key takeaway is to train our pilots how to stay away from Coachella. Managing our software supply chain is just as much about inventory as it is in participating in its open source communities. Take the time to understand where your developers came from and where they're coming from, and enable their ownership of quality and security. And embrace the crazy, because you can't stop the code. Thank you.